Okay, this is Mr. Long again for Balancing and Classifying Equations video number 2. We're going to pick up on number 4. So we're going to have C2. Let me reposition the light here. Let's see if this is better. And it is. Okay, so we got C2H4, and that's going to react with oxygen O2 to produce carbon dioxide and water vapor. Now right away, some of you guys should recognize what kind of reaction this is. So, and it is a combustion reaction because we have a hydrocarbon reacting with oxygen to produce CO2 and H2O. So let's go ahead and write down our elements, count them up. So we got carbon, hydrogen, and oxygen. Now when we're balancing these types of equations on combustion, we're going to save oxygen for last and hydrogen for next to last. Okay, it's better because they're more complicated. So we have 2 carbons on the left, 1 on the right. We have 4 hydrogens on the left, 2 on the right, and then we have 2 oxygens on the left, and 2 plus 1 makes 3 oxygens on the right. So since we're saving O for last and H for next to last, we're going to do carbon. So we're short on the right, so we insert a 2 as a coefficient in front of CO2, and then we're going to remultiply. 2 times 1 carbon is now going to be 2. 2 times 2 oxygens will be 4, plus that 1 on the right is equal to 5. So we'll cross out that and put a 5 here. Now, so carbon is good, but let's look at hydrogen. I think we can see a simple solution there. Insert a 2 as a coefficient in front of H2O, and then remultiply. 2 times 2 hydrogens will make 4. 2 times 1 oxygen will be 2, plus this 4 over there equals 6. Okay, and the easy way to fix that is we have O2 as a diatomic atom here. Remember there are 7 diatomic molecules or atoms. So what number do we put in front of O2 to make it equal to 6? A 3. Put a 3 there as a coefficient. 3 times 2 is now going to be 6. So now oxygen is even, hydrogen is even, carbon is even. So we're good. Let's put a 1 in front of C2H4. Box up the rest of our coefficients. On a multiple choice test, you are looking for 1, 3, 2, 2. And that's your coefficient ratio, your molar ratio, your mole ratio. And this is, of course, combustion. Now, let's look at the next one. And this will be number 5. So we're going to take PbSO4, and that's going to break down into PbSO3 plus O2. So right away, if something is breaking down, you know what kind of reaction it is. It's decomposing, so you can call it analysis or decomposition. So let's look at what we have on both sides. We got lead on each side, but we don't have sulfate on each side. So we can't keep that together. We got to break it down. S and O. Okay, so right away, you got to see what is different. And we have 2 oxygens, and let's add this up. We got 1 and 1, 1 sulfur and 1 sulfur, 4 oxygens, and 5 oxygens. So right away, we're short of oxygen on the left side, on the reactant side. So at minimum, we're going to have to put a 2 here as a coefficient and see what happens. So 2 times 1 lead is now going to be 2. 2 times 1 sulfur is going to be 2. 2 times 4 oxygens will now be 8. Well, lead is not even, so we're going to have to put a 2 there and see how this works. 2 times 1 lead will be 2. 2 times 1 sulfur will be 2. 2 times 3 oxygens will be 6. Plus the 2 on the right equals to 8. Wow, that just worked out. Good thing, because it might have gotten more complicated if it didn't. So we'll put a 1 there. Box up the coefficients. So we got 2, 2, 1 as the ratio, the molar ratio. And what kind of reaction is this? Well, it's breaking down. So we can call this either analysis or decomposition. Okay, it's not so bad. And let's do another one. Okay, this will be the last one I'll do in this video, then I'll give you a few to do on your own. So we're going to have ammonia, NH3, and it's going to react with iodine, I2, to produce N2I6. It's not a good arrow there. 2I6 plus H2. So let's go ahead and break these elements down and add them up. Okay, let's point this up just a tad. Okay, so we're going to have 1 nitrogen on the left, 2 on the right. 3 hydrogens on the left, and 2 on the right. And then 2 iodines on the left, and 6 on the right. Okay, well, we don't have oxygen in here. Well, that's good, so we won't have to worry about that. But we do see hydrogen. He's normally going to be last here. Well, let's look at this. So we know that we have nitrogen. So I would say let's insert a 2 there in front of ammonia. And then we're going to remultiply. 2 times 1 nitrogen is going to be 2. 2 times 3 hydrogens will be 6. So nitrogen is good. But we're short on iodine on the left side, so we're going to put a 3 right there. 3 times 2 is going to make 6, so that's good. And we're short hydrogen on the right side, on the product side. So we're going to insert a 3 right there. So 2 is going to be 6. Oh, that was easier than what I thought. Okay, so let's put a 1 right there and box the coefficients up. And on a multiple choice test, you're looking for 2, 3, 1, 3. Now, what kind of reaction is this? Let's take a look at it. Is anything breaking down? No. Is anything combining? No. Is there combustion? No. Do you see 2 compounds on both sides? No. That just leaves single replacement. We have iodine coming in, and it's going to replace hydrogen, and iodine will get the cheese, which is nitrogen. So this will be a single replacement reaction. Okay, very good. Let me give you guys a couple of questions to work, reactions to work here, and you work them out. So we get first one we have will be H2O reacts with SO3 to make sulfuric acid, H2SO4 when combined with water, hydrogen sulfate. Okay, number 2. we got H2SO4 reacts with ammonium hydroxide, NH4OH. Remember, this is +1 and -1. And it's going to produce water, which is a common product in chemical reactions, plus ammonium sulfate. NH4 parentheses 2 SO4. Remember, sulfate's -2. We've got 2 plus 1s. Here it's +2. They cancel out so they can come together. Okay, well, good. Well, that's your second one. And let's give you a third one to do. You want a third one? I'll just keep it right there. Okay? Well, very good. So it's not too long and hard. Let's go ahead and do those for the next video. And I will see you on the next one.